Namaste. In an earlier video, I talked about this innovation called mgpt, the machine graded programming test that NCST had introduced. And I said we'll talk about it in part 2, the methodology and how we actually implemented it in practice. So that's what I'm going to do today. So meanwhile, view of the Mumbai from Mahim Causeway to the Mahim Worli, and you can also see the ceiling at distance. And so we'll go back to that view once in a while. It's very nice in the morning. So mgpt wanted to basically test problem solving through programming. So basically the input has to be a problem which requires the student to write a program, and the output has to be a program. Now the challenge was if you go with the normal problem setting and some correction mechanism, it is not going to work, because the evaluation has to be automatic, because otherwise the student won't get any feedback whether they are doing the right thing, or whether there are problems in the program. It is not just simply a question of reading a written answer and understanding what is going on. For most people, reading a program and trying to figure out what it is doing is difficult and can be very time consuming. So we needed to find an alternative way. So as I said, we are talking about 20-30 years back in time, and there was not enough AI technology. And even today, given the programs which can take an AI systems, even AI systems which can take a program, evaluate the writing and look at the way the code is written and saying, yes, this is a good program, this actually satisfies the requirement, is still a dream. We don't have that for most of the cases. For very specific cases, the verification, validation, people have actually come up with ways to automatically verify the correctness. But that is not applicable to an open problem statement unless you do a lot of work in creating that specification. So we wanted something that is implementable in more general. So the solution that got adopted was that we will have some hidden test cases. Hidden in the sense the student should not know what those test cases are, because they might tune their program accordingly, or they might say, if this is the test case, then produce the output by manually working out the solution. So that has to be avoided. So test cases will be hidden. It will not be shown to the candidate. And we need a mechanism to look at what is the output produced by the test cases, and you compare whether the system, your student is actually producing those same output. The simple way would be to hard code the output, manually working out the output for each of the inputs, and check whether the student is producing that. This had a challenge, because whatever assumption the person was working on, how do you guarantee that the output is produced by a program of the type that we want the student to write? Are we keeping the same assumptions? All that becomes harder. And if you wanted to change any input, or you want to create an additional input case, that would also be hard. So one thing that got done was that given the same problem specification, the faculty member who's supposedly knowledgeable, who understands things, would actually write a program. Okay, and this is the gold standard program. So given an input, the system would run the faculty program and the student program on the same input and look at whether the output produced are comparable. So if you assume that program is correct and as the gold standard, then if the same output is produced by the student program, then the student program is correct. Okay, so that was the assumption. This also meant some interesting things. One, somebody is actually writing a program according to that specification, and that means whether that the program that we are expecting the student to write is feasible, it is doable within that time frame, and it has a similar complexity. All that also gets tested. If the faculty program works out to be 300 lines or 500 lines and you are expecting the student to do this in 1 hour, we are being unrealistic. So all that feedback also gets generated in that process. And we also make sure that the same assumptions are being brought in. So this has to be verified, because if the faculty program is making a different assumptions or doing a different mechanism, and your problem statement says something else, then this can actually create a problem, because the student would actually have a misunderstanding of the requirement, and we are not being fair. So all of that gets verified by this process of the faculty writing a program, and we also have 2 or 3 levels of guinea pigs. So we actually check whether the output is even manually correct, so that we make sure that the faculty program is adhering to the input specification. So there's a methodology of how the problem is created for mgpt. So somebody comes up with a statement, and somebody else, given only that statement, would actually write the program, and yet another person would actually, given the same statement, create the input cases, and a fourth person would actually do the verification. So this kind of largely ensured that there is fairness and there is proper understanding of what is required. Now the next challenge that we had was that given programming problem and a computer in hand, most people would directly go to the editor. Those days, the text editor was basically the IDE. Today, people would actually start up your favorite IDE, Eclipse or whatever, and then start thinking what is the problem to solve. We wanted to avoid that, because this would give a lot of trial and error way of solving the problem, and we wanted them to think what the problem statement talks about, what is to be solved, what are the inputs, what assumptions are there, bring that down, create a design, and then actually create the program. So the way this got implemented was that we would give the student about an hour or an hour and a half of what is called the writing time. So that time there will be no access to a computer. They will be sitting in a lecture theater or in a classroom with just pen and paper and the problem statement. And we asked them that you read the problem statement, note down the important points, look at what is the input output. We are giving you sample input and sample output, so you know what is the format expected. And you also look at what relevant information is there, what is irrelevant information is there. So create that understanding, create a design, and most importantly, create test cases. Because we are not going to tell you what test cases we are using to test your program. So given the specification, you should also know how to create test cases. And this is a very important aspect of debugging a program, and defining the scope and understanding this. So as I mentioned in the previous video, this is the skill that we wanted them to do. So this time was meant to be used from this angle, but doesn't always work. But it was a good way to keep the computer away and let them do problem solving and thinking. And then we will give them to the access to the computer for another hour or hour and a half, where they would key in this program or from their design that they have come up with, and then debug it. If it may not work, so they have test cases. They will check out those outputs. If that's not matching what they expected, they would want to change the program and all that. And they keep trying as much as required, and you can, as many times as you want, you can ask the system to evaluate and tell you whether the program meets the expectation. But the output is simply how many inputs you got right and how many inputs you got wrong. So it doesn't tell you what the input is, and it doesn't tell you what the problem is. So the idea was that's something that you should not take it for granted. So you should use your own test cases to ensure that your program works correctly. Okay, so this whole mechanism was something that got evolved over a period, and something that became a system by itself. So there is this methodology of how a problem is to be created, what things we should worry about in creating the problem, and how that system should be administered. This whole thing became the methodology for implementing this. So I'll in the maybe part 3, I'll tell you a little bit of the stories and what challenges that this brought to the student, and how this actually affected the way they looked at programming and their experiences and all that. I'll talk about it in the next session. Take care.